Hello, welcome to lesson number 3 in our third unit, factoring, in our grade 10 academic math class. So today we're going to look at factoring tricky trinomials. So this is probably the most challenging lesson in the whole unit, I think. It involves sort of keeping a lot of moving parts going at the same time. So we're going to jump right into it. I do want to say first off that factoring tricky trinomials by systematic trial is not the actual method we're going to use for factoring tricky trinomials today. We are going to get rid of that because I much prefer to solve tricky trinomials by decomposition. So that's what we're going to be doing today instead. Not systematic trial, we're going to be doing decomposition. So we can pretty much ignore all this stuff here because it explains how to do it using systematic trial. I'm going to take you through it using decomposition. So don't pay attention to what's written there, just listen to the sound of my voice. Okay, let's jump right in on example number 1. So again, let's just put this in context. So far we've looked at common factoring and we've looked at simple trinomial factoring. And simple trinomials are quadratics that have 1 in front of the quadratic or squared term. Now this one, as we can see, it has a 2 hanging out front. So this is not a simple trinomial for us to factor. Anytime there's a number out front of our quadratic term that's not a 1, we're going to refer to it as a tricky trinomial, just meaning the procedure for coming up with the contents of our 2 brackets that we're going to have at the end is just a little bit more involved. So I do want to point out before we start here in the way that we've been thinking about it is that prior to this we've been working with just single x's here and then a number and then a number. And the way that we've been figuring it out is these 2 numbers, whatever they happen to be, they have to multiply together to give us the last term. But what's interesting is that having potentially numbers other than 1 out front of our x terms as a whole new dimension that we have to consider. Because when we expand this out, we see that we're going to have those 2 first terms creating a number in front of the x squared, and then this is going to be an x term that's not just impacted by this value here, it's also impacted by whatever value is here, which means that this a value, it needs to be considered as we look for the things that multiply or that add to plus 7 and that multiply to, well, 5 just won't work for us anymore. We need to find something different. So the way that we're going to do that is we are going to look for the thing that multiplies to, what I'm going to write down here is a times c. So a is the coefficient in front of the squared term, and c is our last term. So in this case, we're looking for something that's going to multiply to plus 10. As I said just a second ago, the reason that we're doing this is because the 5 is no longer the only factor contributing to the values that we end up with here in the middle, the plus 7. So we're looking for something that multiplies to plus 10, but that adds to plus 7, which is the same b value that we had before. So in the spirit of kind of keeping this transparent, let's just do that same thing that we would do before. What are 2 numbers that multiply together to give us plus 10? So that might be like plus 10, plus 1, minus 10, minus 1, plus 5, or sorry, plus 2, plus 5, and minus 2, minus 5. So those are our integer combinations. So those are the things that multiply to plus 10. Which combination, when added together, gives us plus 7? And we can see it's going to be this guy right here. So if this were a simple trinomial, those would be the 2 numbers that automatically go inside the bracket. But that's not going to be the case here. What we're going to do is we are going to decompose this middle term down to the 2 numbers that we just saw, 5x and 2x. These are the 2 numbers which, when combined, give us our 7x, and those were both positive. Now what we're going to do out front is just write down that first term in our trinomial, the quadratic term, and at the end we're going to write down the last term. So what we've done here is kind of a hybrid version of what we were doing with simple trinomials. We were trying to find the values that multiply to plus 10, which is the product of our A and C values, but that add together to give us our positive 7, the B value, same as last time. So we determined those two values were going to be plus 2 and plus 5. So what we did was we decomposed plus 7 down into those two pieces. Hopefully so far so good. Now what we're going to do, I'm going to change up my colors here, we are going to do common factoring. So we're going to look just at these first two terms. We're not going to pay attention to this guy right now. We're just going to be looking at the first two terms. And from the first two terms, 2x squared plus 5x, what is the greatest factor common to both of them? And we'll see that it is just a single x. And when we common factor that x out, we are left with 2x plus 5. Hopefully that makes sense. Now, the piece that we were ignoring is going to switch. Now we're going to ignore these first two pieces because they've already been factored, and we're going to look at plus 2x and plus 5 and find the greatest factor common to both of them. Now interestingly, the only factor common to both of them is 1. So we're going to write down plus 1 as the greatest common factor, and that's going to leave us with 2x plus 5 in that last bracket. So there we go. We've taken a common factor from the first two terms, and then we common factored the second two terms as well. So far so good. So now what we have left here is one term and two terms, and we're looking for the greatest common factor in those. This calls back to what we were doing in the extensions part of our common factoring lesson, because with these two terms, the greatest common factor is actually this binomial. 2x plus 5 actually shows up in both terms. So that is my greatest common factor. And when I factor 2x plus 5 out of the first term, so that's this piece here being factored out, I'm left with an x. And when I factor 2x plus 5 out of the second term, I'm left with a plus 1. And that is how you factor by decomposition. Now I just want to do a check on this. I think I left enough space over here. Yes, I did. So that was 2x plus 5, 2x plus 5, and x plus 1. And what I'd like to do, just to sort of prove this, or maybe unpack a little bit of the complexity of it, is to just expand it out and simplify it. So expanding out, we get 2x squared plus 2x. And now we do this one plus 5x, and then we do the last one plus 5. So what's interesting is this line, when we are expanding out, is exactly the same line we built right here by decomposing that middle term, that plus 7x. And as we finish this up, by gathering together these two like terms, we end up with 2x squared plus 7x plus 5, which is what we started with. That's a good thing when you're factoring, to expand it out and get what you started with. There it is. And that's how you factor tricky trinomials. So what I'm going to do is I'm going to stop this video here, and then I'm going to do a second part where we work through all of the examples. So hopefully this explanation helps. If you're still not 100% sure what's going on there, maybe just watch this video one more time. I'm going to move more quickly through the subsequent examples. Not like lightning fast, but definitely quicker than maybe it would be if you'd just seen this video just once. So maybe watch it twice if you're not sure what's going on, and then we'll see you in part 2.